before you work on them, you can cancel top and bottom by 2. You get 3/2 also, right? So this means this is also omega 1, right? So similarly, so these two are same frequency, so I'm going to call them omega 1. So you don't have to do 2 times. You don't have to find the period 2 times. It's understood they're having the same period. Merely this period here, you can call this omega 2. We're going to simplify this. You can divide this by 2. You get 4. You can divide by 2, you get 9. So also same frequency as omega 2. This is also omega 2. So therefore, you don't have to do 2 different calculations for the same period. So there's only 2 frequency involved here. So you only calculate 2 frequency, 2 periods. Omega 1, number 1. Omega 1 is 3/2 pi. Sorry, 3 pi over 2. And T1 is 2 pi over omega 1. 2 pi over 1 multiplied by 2 over 3 pi. Is it okay?
Okay, sir.
So, okay, then if you cancel these 2, then you will get a T1 is equals to 4/3. So you do the same thing for the other side, for omega 2. So first you have to determine how many frequencies are there. So you have to simplify before doing anything. So omega 2 is 9 pi over 4. So T2 is 2 pi over omega 2, which is 2 pi over 1 multiplied by 4 over 9 pi. So that's going to give you T2 is equals to pi's and pi's cancel. So you're going to get 8/9. Then you have to conclude it's not, if it's one of them is not sorry, the numerator is an integer, the denominator also is integer, numerator integer, denominator integer, so it's a rational number. Rational number. Now next you have to find the period. To find the period, you have to do T1 or T2 is 4/3 multiplied by 9/8. So you cancel this 3, cancel this 2, 3/2. Am I doing this right?
Yes, sir.
Okay, so 2T1. So period, so if you cross multiply this, you're going to get 2T1 is equals to 3T2. So period is 2t1 or 3t2 period. If we are using t1, then period is going to be 2 multiplied by 4/3, which is 8/3. So that is the period. Period should be in seconds, not kilograms or meters. In this case. So you could have finished these questions in 5 minutes. Okay. If you can finish this question in 5 minutes, you have more time for other questions. Because I was explaining, it was taking a little longer, but actually you can finish this in 5 minutes. So the next problem is finding the Fourier series coefficient. Now you can see this periodic signal, they are repeating. Okay. So this periodic signal, it has an amplitude 1, and this signal, the width of the signal is minus pi to pi. That is, the width is 2 pi. Okay. So this signal is being as a period, if you take from center to center, it's a period. Period is 10 pi. This value is 10 minus pi, because we know the width of this is pi, right? From here we know the width from here to here is pi. The width from here to here is also pi. So if you subtract pi, this is 9 pi. This is 11 pi. Okay. So you know your period. So you know the pulse width, and the pulse amplitude. So let's go and calculate this for question B, question 2. We can calculate F naught, which is DC. DC is 1 over the period, 0 to period. You integrate the signal over a period and divide by the period. The period is 10 pi. So you're going to integrate from 0 to 10 pi. But the thing is, this is a signal. If you go and look at the period, it depends on which period you're talking about. If you're going from 0 to 10 pi, say if I'm going to go from 0 to 10 pi, in this interval, 1 over 10 pi, the period going from 0 to 10 pi. I'm going to break this into two integrals. The reason for doing this is because in the period under consideration, under the consideration, we have one area from 0 to pi. And then we have another area from 9 pi to 10 pi. Okay, so we have two periods, sorry, we have two intervals to do the integrations. One interval is from 0 to pi, the other interval is 9 pi to 10 pi. One interval is 0 to pi, right here. The period under consideration is 10 pi. In this period, we have two areas, one area here and another area here. There's nothing in here. So you cannot be integrating everything here that's here. It's zero signal here, so you're not going to include this in your integration. So you have to integrate only where the signal exists. Signal exists here, and it's existing here. It exists in this interval 0 to pi. Another interval that it exists is 9 pi to 10 pi. Zero to pi. And one is 9 pi to 10 pi. In this interval, what is the amplitude of the signal? From 0 to pi, the amplitude is 1. And also from 9 pi to 10 pi, the amplitude is still 1. Then you integrate. Either you can integrate or you can simply go here and see that integration is area under the curve. In this case, this area, this part of this area is 1 times pi, right? It's a smaller piece of rectangle, which has a width pi. And the height 1. So the area is 1 times pi. Area is 1 times pi. Similarly, the area is 1 times pi, and the area here also is 1 times pi. So 1 times pi is pi. So area, okay. So area is so I can replace this with pi, and I also can replace this with pi. Pi plus pi is 2 pi. Two pi over 10 pi is 1 over 5. So therefore, F naught is 1 over 5. Next, find Fn. Any question on this?
No, sir.
Next, find Fn. Fn is the Fourier series coefficients. Before finding F1 and F2, you have to find Fn. before finding Fn, if you go and give me F1 and F2, definitely you're going to get a 0. So it's going to be 1 over t, 0 to t, and then ft, e to the minus jn pi t. Is this the right formula I'm using? I'm also recalling from a memory.
Correct.
This is not right, right? This is pi. This is
Omega, right?
Omega naught.
omega naught pi, or simply omega pi also is fine. In this case, since I'm calling this, if you call this omega naught, then you have to call this t naught. Sorry, not that. We call that omega naught, then you have to call this, you have to call all this t naught. Okay. So omega naught is omega naught is 2 pi over t naught, which is 2 pi over, what is t naught? We calculated earlier. That was given. What is t naught?
10 pi.
Huh?
10 pi.
How many pi?
10.
If you come here and look at this t naught from the signal here, going back to the signal, so this is t naught. Now what is t naught?
10 pi.
Right.
Oh, just now you said n pi or 10 pi.
10, sorry.
Okay. So 10 pi, 2 pi over 10 pi. So that's going to give you, this is okay. So 2 omega naught is how much? 1 over 5 radians per second. Okay, so far, is it correct that because I'm doing this the first time, I don't have a solution for this midterm? So am I doing this right? So please check, don't assume that I'm right. Omega naught is 2 pi over t naught. And then 2 pi is 2 pi, and then divide by t naught is 10 pi. Pi's and pi's cancel. Omega naught is 1 over 5 pi. Sorry.
Omega naught.
Okay. That's what I'm trying to get. Actually, I forgot the formula myself. So omega naught is 10 pi. Omega naught is 1 over 5. So if you're confused, you can always come and check whether you're doing it right or not. You don't need a solution manual or any answer. You can always check. If omega naught is 1 over 5, then t naught is how much? You can check back to make sure that you're doing it correctly. So, okay, it checks, so you're doing it right. Because once you get the period wrong, then the whole solution is going to be wrong. So 1 over 10 pi. So again, the integral involves two parts. One is from 0 to pi. 1 e to the minus jn. Put this somewhere else. The one is from 0 to pi. E to the minus jn.
1 over 5.
Huh?
1 over 5t.
Okay, 1 over 5t. And then dt plus 9 pi to 10 pi. Also same thing. 1, right? 1 that multiplied by e to the minus j and 1 over 5. 1 over 5. Okay. Is it all right so far?
Yes, sir.
Okay. So can I continue? Can. So 1 over 10 pi. So I'm also doing this the first time. So please make sure that I'm doing it right. So integrate this. E is 1 over minus j and j
Jn 1 over 5.
jn over 5. Jn over 5. Or just 1 just 1 over 5. 1 over 5n. E to the minus j and minus j 1 over 5 and t plus, so you're going to integrate from 0 to pi. On the other side, the same thing, 1 over minus 1 over 5 and integrate minus j 1 over 5 and t. We're going to integrate this. We're going to integrate from 9 pi to 10 pi. Okay, if you want to simplify the algebra, you can bring the, before you substitute numbers, if you want to simplify it, you can just factor out the minus 1 over j. We can factor this out. Factor this out for both sides. It's going to be 5 over jn. I recommend don't play with the algebra too much at this point. Don't try to bring the j to the numerator, denominator. That all you can do later. You just factor that out. And then next inside here, you're going to do, you're going to substitute minus j 1 over 5 n, and then you're going to substitute the pi here, upper limit, subtract the lower limit. We subtract the lower limit, it's going to be j 1 over 5 and 0. So on the other side, plus e to the minus j upper limit n pi so this is and it looks like pi. So if you bring them out, so the pi is missing here. So if you look here, this 5 will cancel with this 10 here. 5 will cancel with 10, and this is 2. 1 over 2 pi jn. So it's going to be, I forgot, okay, I have to remove this parenthesis. Okay. So 1 over minus 1 over 2 jn.
So the pi is missing, is it?
Or jn pi. Okay, thank you. So then inside here, it becomes e to the minus j n pi over 5. And then e to the power of 0 is 1, so it's 1 here, plus e to the power of like 10 over 5. So that's going to be e to the minus j 10 over 5 is 2. That's 2 n pi. And then minus e to the minus j 9 pi over 5. Okay, so this is your Fn. If you can get this, it's good. So you
So
don't have,
9 pi over 5 n, is it?
okay, thanks. Sometimes the pi is missing. When pi is around, then n is missing. Pi over 5. So this is Fn. If you can get this, then you can just plug in, F1. n equals to 1. And f1 is, you just replace wherever there's n with 1, minus 1 over 2j pi. N is 1. 9 pi over 5. You can just leave it like this. So in this case, since we are only dealing with n equals to 1 and 2, we're only dealing with n equals to 1 and 2, you can individually go and check this out. What is cosine 2 pi is going to be. Okay. So f1 is going to be, you can just leave it like this. Or if you want, you can just evaluate this and say this is 1. Then f2, just multiply, you're going to have n equals to 2 now. So it's going to be 1 over 2j 2 pi. So wherever there's n, you're going to put 2. Minus j 4 pi. And then this is going to be minus j 2 pi over 5. And then on this side is minus 1 plus e to the minus j 4 pi. So again, this also is going to give you 1. But anyway, this is a short exam. You try not to waste time in trying to simplify this. It's sufficient if you can do this. It's enough if you can do this. This and this. Okay. Maybe in the assignments you can have a lot of time, you can simplify things, but for now you can just leave it like this. And that's all for the Fourier coefficients. Next, any question here?
No, sir.
The next question is evaluate the discrete time convolution. Xn is u sub n. H of n is u n plus 4. So before you do the convolution, you change variable. Change variable first. You let n equals to k. In this, one of them, you let n equals to k. It can be any one of them. You can either choose n equals to k in x of n, or you can choose n equals to k in h of n. So I plan to, you can either replace this with the k, or you can replace this k. One of them must be replaced with k. If you replace this with k, then you must replace this with n minus k. If you replace this with k, then you must replace this with n minus k. Both will give you the same answer when you, after you do the convolution. In this case, I've chosen, I'm going to let n equals to k in x of n. So that's going to give me xk is equals to uk. If I chose n equals to k in that one, so in this one, I'm going to choose n equals to n minus k. Okay, so don't have to worry about doing this. You know, you really don't have to worry about replacing all these things here. That will confuse you. So from now on, what you can do, you only think graphically. You have to sketch this out. Sketch this out. First, you sketch x of k. First, sketch x of k. X of k, you have a signal starting from, a signal starts from 0, 1, 2, 3, and so forth. Hn minus k. Before you plot Hn minus k, I recommend that you plot h of k first. We go step by step. We do things graphically here. First, you sketch h of k first. Start with the basic signal first. H of k is same as replacing the n with k. So if you replace this n with k, this h of k is just simply u n plus k, k plus 4, something like this. So this is a signal that's going to start at when n equals to minus 4. So n equals to minus 4. Minus 4, minus 3, minus 2, minus 1, 0, 1, 2. So this signal is going to start here. So all these signals have amplitude 1. And moving in that direction. So there's 0 right here, 0. Okay, then you plot h of minus k. Next, you plot h of minus k. You will be just flipping the signal around 0, about 0. In that case, what will happen is, if you flip the signal, signal h of k. This h of k, and then you're going to flip the signal about 0 right here. When you flip it, what's going to happen is all this negative sign here become positive. -4, -1, -4, -3, -2, -1 becomes 4, 3, 2, and 1. And the signal now is moving in this direction, but now the signal will be moving in the opposite direction. I mean, after when you flip, this is the way to look at it. The next, what are you going to do? You're going to, so far, any question?
No, sir.
Now you're looking for n minus k. So you already have minus k plotted there. You already have minus k, this part minus k is plotted. Now you're adding n to that. See right now, you had earlier minus k plotted. Now you're going to just add n. Okay. So now you're going to just add n. So h minus k I just drawing this from the h minus k signal. Let me draw this. Let me copy and paste it here. So now we're going to add n. Minus k plus n, or n minus k is the same thing. We're going to add n to all the signal, and we don't know what n is. N can be minus number, can be a negative number, positive number. So we just going to add n. We are not going to minus n, because when you subtract n, later on, that depends on what the value of the n going to be. If it's going to be minus, it's going to go one direction. If it's going to be plus, and it's going to go in the other direction. Okay, so when you add n, so all this becomes n plus 4, n plus 4, n plus 3, n plus 2, n plus 1, n plus 0. So for now, we don't know what n is. Depends if n is 0. If n is 0, then it's going to be, if the n is 0, then it's going to be same as this. If n is minus 1, then it's going to be shifted on the left, to the left side. If n is positive 1, then it's going to be shifting on the right side. Right? So for now, we don't know what n is. This is what you need to do. We go and try not to do this mathematically. We do it graphically. We're going to use and slide this through x of k. I'm going to take this and slide this way. So when you're sliding, when n plus 4 is less than 0, there's no overlap, right? See, right there. When n plus 4 is less than 0, there's no overlap. N plus 4 is less than or equal to 0, no overlap. This means n is less than or equal to minus 4. No overlap. So therefore, yn is going to be 0. Okay, that part. Next, you start sliding this. Always there's a problem in spacing. So now I'm going to take this and slide through. So now n plus 4 is aligned with 0. N plus 4 is aligned with 0. N plus 4 is aligned with 0 here. This is 0. This n plus 4 is aligned with 0. So once n plus 4 is equal to 0 or greater, now n plus 4 is equals to 0 or greater, you're going to get overlap. You can start overlapping them. You slowly overlap, 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 and then you come until here. Okay, you come until here. You keep on going. You can continue to go, because you can continue to go up to infinity, because this is going to infinity, right? This is going to infinity, so you can keep on sliding. You keep it sliding. You can continue to go on up to infinity. Okay. So the upper limit is controlled by, so n is greater than 4. So the k is, we can see, oh my God, let's see. So when you continue to slide through, the upper limit of k, the lower limit of k is 0. This is a lower limit of k. K is 0 because less than 0, there's no signals. There's no signals. So the lower limit for k is 0. The upper limit of k is what? The upper limit of k, because I said earlier, you can continue to slide this. And how far you're going to slide, that depends on the value of n. If n is 10, then you can go until 14. When n is 100, then you go up to 400. If n is infinity, you can go up to infinity. So the upper limit is controlled by n plus 4. Therefore, why now signals are overlapping, then therefore things are convolving, right? So both of them as an amplitude 1. So 1 times 1 is always 1, so no problem. That 1 times 1 is 1. And then lower limit is, so n is from going from where? What is the lower limit? Lower limit is k is equals to n plus 4. Sorry, k is 0. Upper limit is n plus 4. Either you can put the one here or you can put one on the back. Both of them are same because one is not independent, so it's considered like a constant. That's going to be upper limit minus lower limit plus 1. So n can have any value. N can be infinity, maximum. So the minimum value n can have is -4 or greater. Yn is going to be n plus 4 minus, so it's going to be n plus 5. N plus 5. Okay lah. Any question? Any question?
No, sir.
So see, I
No, sir.
start. So you can see I started the class late, and then I really finish it in about in 1 hour, and I was explaining things. If I was not explaining, I could have finished this in half an hour without any practice. I did this writing the solution. Of course, I looked at the problem earlier and then roughly get an idea what to do. But then maybe I only thought about this for 1 or 2 minutes. So you could have finished it as a student if you're practicing. You can be quicker than me. So you can finish this in half an hour. So I took 1 hour because I was explaining, and you see I was making mistake also. I was just like a student like you guys, making mistakes and moving. And I haven't had my morning coffee yet, so but don't spend too much time on that. Quickly upload. After you're done, take a scan, a photo, practice a few times, and quickly upload. I would recommend that you just stop writing in about 45, 50 minutes. 45 minutes, you should stop writing and just check in. It's not a difficult exam. You can make this very difficult if you like. Who want it more challenging? Or this challenge is enough?
This is enough, sir.
This one enough, sir.
So the others one more. Only 2 of you saying enough, right?
So this is
Enough,
more
sir,
than
enough.
enough.
This is enough, sir.
That's why it's going to be due after your midterm. Actually, you can do this in 5 minutes. To be honest with you, I'm not really saying. Those who have done, taken control system should be able to do this easily. If you haven't done control system also, no problem. You can just go and check the internet, just Google, see how to solve differential equations in MATLAB or Simulink. And there's a lot of people doing this. You just do it and you'll be done in about 10 minutes. Once you find how to do it. So this is the lab, very short lab, you see, that's all. In the simulation laboratory, so you have to solve this differential equation. You know how to solve this differential equation by hand, right? with the initial conditions. So you just do n calculation and show your plot. Plot must be very clear. Or plot must be made very clear. Neatly done. Neat. Neatness will give you a lot of points. You don't have to do very much of report writing. I don't want to see you writing too many things. Just do just a small, simple objective statement. Objective statement, you know how to solve the differential equation in MATLAB or Simulink. You can either use Simulink or MATLAB. In a MATLAB, Simulink is available. You just go to the command window and you type Simulink, it will come out. It will be much easier than MATLAB code because you'll be just pull out some block diagrams and you solve it. All these things become very handy when you do your final year project or something like that. So I recommend that you solve it. By solving by hand, you know how to solve this, right? You guys know how to solve this, isn't it? You have done this in, we have done this in mathematics 1A or 2A, I don't know, one or the other. You can either solve this by Laplace, or you can use one of the differential equation techniques we already talked about. Solve it by hand, and then you just plot. When you plot, you know, you'll get something like this, right? You'll get something like this, or you get something like this. Any question?